Hello everyone, so we're being kept away by the wind today. So instead of our usual lesson, you've got a bit more of online learning. So here we go with, we're starting a new topic of vectors. If it troubles you, or if you just want to get ahead, I did make some videos that some of you did back in year 11 for higher GCSE vectors, and I've attached those on class charts as a playlist, so you can have a go at those. One, if you're confused, just because it gives another way of looking at it, but two, if you maybe wanted to get a little bit ahead so that you don't feel overwhelmed by vectors when we come back after half term. Anyway, have a nice break and enjoy the vectors for today, and remember, as ever, always pause the video and have a bit of a go at what you think you should be doing before you just let the video roll and carry on. So pause the video now and have a crack at these. Right then, so using a ruler is a good idea, but we're also just about sketching as much as anything and looking. So A plus C is what you would get if you went down 3, 6. So if I start here, go down 6, 1, 2, 3, 4, 5, 6. That's done A. Then plus C, well, C is 5 squares to the right. 1, 2, 3, 4, 5. I love vectors, by the way. Some people hate them, but the more you play with them, the easier they get. Now, the resultant, as it's called, of A plus C is actually this vector here. So that there is your A plus C. So have a little go at negative B. I think I'm going to have to start it up here somewhere, because a negative just does exactly the opposite. So it's going to be parallel to it, but going in the other direction. So this is what? Down 1, 2, 3, 4, 5 and across 2. Down 1, 2, 3, 4, 5 across 2 to there. And then if I do the same again, 1, 2, 3, 4, 5 and across 2, that gets me to there. So actually that's just going, because it's only the one thing, I can just put that on there. Oh, hang on, I've not done negative b there, I've done negative 2b. Let's pretend I asked you to do negative 2b, shall we? Okay, there we go. Right, now there's going to be a bit of magic technology, high-tech drama going on here. We're going to do 3 and 4. Oh, there they are. So, pause the video, have a little crack at these. So 2c plus 3d, we don't actually have to go up too far because it's going to end up going down. So c is 5 to the right, so 1, 2, 3, 4, 5, that's 1c. 1, 2, 3, 4, 5, that's another c. And then 3d, well, that's going diagonally down to the left, a bit more technology. That's 1d, that's 2d, and the third D is that. So that's going to give me a resultant. I started there, I finished there, so that means my resultant is going to go straight down there, like that. That is 2c plus 3d. Not as far, but there you go. And that's all we're doing. So a minus 2b, A is going down, isn't it? 1, 2, 3, 4, 5. That's your A. And then negative 2b is the same as what we had up here, wasn't it? So it was down 5 and across 2 twice. Let's do that. 1, 2, 3, 4, 5 across 2. And again, 1, 2, 3, 4, 5 across 2. That's your negative 2b, so your resultant is going to have to be from there down to there. Now, getting the hang of that is key to spotting what we're going to have to do in our later ones. Right, now you could have a question like this. Now, what's going on here? Are we still talking about the A that was 6 down and the B that was 2 to the right and 5 up that we had before? We might be. but actually it doesn't matter. Whatever the vector A is, wherever it's going, if it's always the same, and then B is always the same as whatever you've defined B to be, things will be parallel if they're just multiples of each other. If you think back to that when we had B doing, or let's go for that one that was D. That was just doing that, wasn't it? Now, if you had 1.5 times of that, that would look like. Oh, I've done that. Have I done that right? Yeah, 2 across. That would be 1 times, and then half of it again would be down to there, wouldn't it? 1.5 times it, and it would be parallel to it. So if you can multiply both vectors by multiply a vector by a single number and get the other one, they must be parallel. And the numbers 6 to 9 and 8 to 12 key in. What they're asking you to do here is a kind of factorization where you take out, what is it that you multiply 6 by to get to 9 and 8 to get to 12? We can always use a calculator if you like, but it's 1.5 times. So all you would have to do for this is to write that 9a plus 12b is equal to 1.5, or you can write 1.5 if you prefer that. We all know who doesn't want a fraction in there. And then put 6a plus 8b there. Because 1.5 6s are 9 and 1.5 8s are 12, they would become the same thing. So the fact that you can multiply 6a plus 8b by 1.5 and get the other one proves that they are parallel, and that's all it is. Okay, here's another question for you to have a go at. It should be familiar from GCSE times. So you've got to get from P to S, and the game is you're allowed to use these movements, which are defined as A, B, C and D, going from P to Q. Well, actually it goes from Q to P, doesn't it? But we want to go from P to S, so we can only use movements that are like A, like D, like C or like B, but we're allowed to use negatives of them. So first of all, to get from P to S, we could go from P up to Q and then down from Q to S. So P to Q is going against the arrow, so that would be negative A, and then that's plus C. Now if you want, you can write it as C minus A. That's a bit more elegant, so that's probably what I would do, but it wouldn't matter because that would mean doing that that first of all, and then the reverse of that, and that would end up back in the same place. Right, R to P next. So we can't go across here. We're going to have to go up to B and then down to A. So up to B, that's negative B, and then that's positive A, isn't it? So we could call that A take B, or negative B plus A. Then PT. Right, we're going to go all the way around the houses here, to there, to there, to there. So it's negative A, it's positive B, and it's positive D. So I could call that one B plus D take A. And then finally we've got T to S. So this is a strange one, isn't it? I've got to go up to R, up to Q, and then down to there. So it's very similar to that one in that we're very similar to the one before, but we're going to that, and we're starting from the end point of the last time. So it's negative D, negative B, and plus C. So I'm going to call that C take B take D. But you could have it the other way round, it would be fine. Right, so here's the next one. ABCD is a parallelogram. So what we need to do here is find A to C. Well, because it's a parallelogram, that means that A is also the same as that bit there, isn't it? That's exactly the same as that. So that's all we need to do for this. You've just got to do B plus A or A plus B, because you could go along there and then up there. That would be the same, wouldn't it? So there we go. A plus B. That's all that one is. just in case you're finding it a bit too easy, let's bring some ratio into it. So you're definitely going to have to pause this one for a little while and have a think about it. Okay, so I think I'd start off with this one by putting, that's confusing having that P there, isn't it? But maybe use another colour and just go in there and say, right, A to B is A to C is B. And I want to go from B to C, so it's going against A, isn't it? And it's going with B, so that would be B take A, or negative A plus B. Then A to P. Well, A to B is A, isn't it? And P is the midpoint of AB, so it's halfway along. So I've just got to go half that distance, so it's going to be a half A, or you could write A over 2, either's fine. A to Q's a little trickier, so we are going from A to Q, and that is the ratio of 3 to 2. Now if you split something in the ratio 3 to 2, that is splitting it into 5 equal parts, isn't it? You've got your 3 and you've got your 2, and the Q is happening further down there, isn't it? There. So you've got to think about what fraction of going from A to C it is. Well, we've got 5 parts in 3 to 2, so we add those bits of the ratio together, and we say we're going to go 3/5 of B. So if you had been confused by PQ, maybe now that we've done that, might be a good time to pause and have a go. Right, so from P to Q, I'm going to do PA plus AQ. And PA, I know, is going against A, but it's half of it, so that would be minus a half of A. And A to Q, we've already defined as being 3/5 of B. So it's going to be that. And you could rewrite it again if you like to be 3/5 of B, take a half A. And we're just about done, but what I'm going to do now is pop 1 or 2 more questions down from the book, from the problem solving ones, and I'm not going to go through them right now. You can have a go at doing those, and if you've got the answers in the back of your book, you can have a look at them from that. So I'm going to put those up now. Okay, so these questions are on page 234. They are on exercise 11A. Answers are obviously in the back of the book anyway, but if you do have trouble with them, if you want to email me, I'll get back to you on it. And I'll see you after the half term. Now there is just one more thing. I'm going to put another homework on to ask you to cover as much as you can of the Review 2 exercise, which is just after chapter 10 and before the one we're doing now of chapter 11. And I'd like you to, sort of having marked your own work on it, I'd like you to sort of come prepared after half term with one question that you reckon you bossed, so from one topic that you're really happy with, and then also one question that really ground your gears. Okay, see you then. Have a lovely half term, everyone. Cheerio.